Hello, my name is Andrei and working on a civil project. So today we'll show you with Xian the new civil functionality for BricsCAD V20. So when we started the civil functionality for BricsCAD, we had quite a good idea how the design or modeling of civil objects or infrastructure objects. By that I mean long linear objects like roads or rails or even some earthworks should go. But there were some challenges. For example, it needs to be the modeling. It's the modeling basically. Then it has to be easy to use because we would like to approach this technology not just for civil professionals but also to architects, surveyors, such kind of profiles which are not all the time on the civil design. It has to be accurate and powerful. And it has to be the platform at the end because we are working on platform. So for this demo, we will show you how you can use the civil features to design the conceptual design of the road accumulation. We'll do some building path. So first, we started with the surface. Surface is kind of main or core entity which can be used to represent existing ground, as in this case, or it can be used to represent some surface layers or some sub-layers of the, let's say, of the design. And in this end of this valley, we will create an accumulation dam. So to do that, we'll first create a simple line, and that simple line defines the crown of that accumulation dam. So from this element, we'll first use the grading entity and create offset and slope grading to the left and to the right side to design the top surface of that accumulation. Then we'll use the grading several times to create a side slopes for this accumulation dam. And all the gradings are so dynamically connected with the, let's say, reference elements, in this case, the line. So if you move the line, as you can see, the design updates automatically. It does not update in the real time with a full precision, of course, because we wanted to make it fast and help designer to see what will be the result of that move. So it's created with some, let's say, not full accuracy to be fast, but when you release the mouse, it's created with a full precision. Then if you, for example, change the width of the first grading on the right side, also the second one updates because they are connected. So all the entities have the logic inside to be connected to enable this, let's say, functionality and expected behavior. So next, we would like to calculate the volume of this element. So how to do that? First, we need to merge or to join so different grading elements into a single surface. So now we have two surfaces in the drawing, so existing ground and that the second one which represents the accumulation dam, and we can calculate the volume just by selecting two surfaces. So the thin volume surface was created, and then that is, let's say, another entity, part of the civil, let's say, platform, and you can see some custom properties like cut volume and the fill volume. So you can immediately see what would be the volume of that element. So, and then you can, of course, you can play with it and see the results immediately. Not just the volumes, we can also create the solids. So if we have the surfaces which, let's say, closes the body, then you can create a solid or mesh in this case from such irregular geometry. Okay. So now we will use merge surface again to combine those existing ground and the accumulation surface into one surface, and we will use that, let's say, combined surface for the further design. So now we'll do, we would like to do some building pad. So first, we would like to put the building pad somewhere there. But as you can see, the surface, it's kind of bumpy. So we have this so-called Smoothen command, with which you can, let's say, go over the surface, specify the radius or any other closed polygon, and by, so let's say, selecting the area, this part of the surface is flattened or interpolated to get kind of smooth result. So it could be very useful for some, let's say, landscape architects if they get some surface from, let's say, not so nice data, to polish it a little bit and to have a nice, let's say, surroundings. For the building pad, we can create a building pad, let's say, in two ways. First, use deform surface command. So we select the polyline, define the inner boundary or offset, and with just this push-pull effect, we can elevate the bottom of the building pad to some defined elevation. So this is very handy if the outer and inner boundary of the building pad is defined and when it shouldn't change. But when we have the situation that we know the footprint, the one footprint, and we know the slope, then we can use the grading technology. So the grading technology helps you to create the side slopes with a certain angle to find the intersection to the existing ground, and such let's say, irregular geometry is created. So again, the grading is a custom entity with some specific properties. Again, it is also, as you can see, it is related to the existing entity, and if you move around, it updates in the real time. So, but this functionality thank you. This functionality works also on large examples, not just on small ones. So then you really have a full freedom to find the right position, to set the right elevation. You can even select the side slopes and change the slope with the grips, or you can change the slopes in the properties, and you can immediately also see the fill and the cut volumes. So once this building pad is, let's say, set up, then you can use it to position, to place some buildings on top of it, and use it for some design. Okay. Now, what we would like to do, we would like to design the road. We'd like to create a conceptual design. So we are not doing the detailed design, but conceptual design. The road which goes from that one, the existing one on the right side, over the accumulation dam, over those hills, passing by the building pad. So to design the road, we need the alignments, because the road or other linear objects they are twisted in space. They are twisted in horizontal and vertical direction. So you cannot just use simple polylines or any other known geometry in CAD. You have to use the proper geometry, and proper geometry means that you have straight segments, you have curves in horizontal, in vertical direction. You could also have spirals. We do not have spirals at the moment. We'll add them next year. And by those alignments, you can precisely define the center line or geometry of the road or other linear object. So designing the alignment, basically traditional way goes like this, that you design horizontal alignment in plan view and you design the vertical alignment in the profile view. We wanted to upgrade this to bring the new approach. We wanted to be able to design the alignments directly in the 3D space. So by doing that, we had to develop some, let's say, some technology which could help you to do that. So let's start with the alignment. You start the command, select the surface, and then you can, if you watch precisely, you will see near the cursor, here's one small circle, which helps you to precisely define the position on the surface. Otherwise, if we wouldn't do that, you get very quickly lost in the 3D space. So to offer the designer some, let's say, navigation or better orientation in space, we introduced that. And so she created the alignment. What she did, basically she created alignment in 2D. It's a horizontal alignment. Then the vertical alignment, so the surface alignment, was automatically generated on the surface. That's the blue line. And also the design profile or the design vertical alignment was also created automatically. So to enable this initial proposal of the design. Of course, we enable also the traditional workflow where you can design the profile manually, but this, let's say, automatic approach gives you the first, let's say, approximation of the object very quickly, and it is also dynamically. So here in the profile view, you can see we have two lines, the blue one which represents the projection to the existing ground, which is bumpy, and the new one which is smooth, and that is the design, because the road at the end it needs to be smooth. And if you select this vertical, so the design profile or alignment, you can see we have some setting called accuracy factor, and with this parameter you can specify how this vertical profile is aligned with the existing surface. So this value goes from 1, which means we have a straight line in vertical direction from start to the end point, to 100 when it means that we consider all the points. All the values in between helps you to approximate this. So if we put now value, for example, 5, it's closer, it gets closer. If we put it 10, for example, it's get more close to the existing surface. And by that you can control very easily the first approximation, and automatically also those entities, so for alignments we have horizontal, vertical, and 3D, are connected, and they are updated automatically. So now we have the alignment. We have the 3D alignment, and we will again use the gradient technology to create a road surface aligned with that alignment. So if you so let's say this is our first, let's say, version. So if we select the 3D alignment, you can see we have some special grips. By moving the grips, you can directly edit the 3D alignment. So no need to go to the 2D view, to plan view or profile view. You can do the edits of the geometry directly in 3D space. This is something that you cannot find in other CAD, CAD platforms or products. If we now switch from automatic to manual update mode, you can see that we have some additional grips, more arrow looked like, and now with those you can edit the geometry in the vertical direction only. So, and you can see the grading follows. And what is the beauty of this? That you immediately see how this, let's say, object or let's say road in our case will be positioned in the on site. Okay, so once we are happy with the road surface, then we can create side slopes. For side slopes, we will use the grading again, select the existing one, select the surface and set the slope, and we get, yeah. So if the objects are along, it might take some time. So we put the notification so to change the tessellation value to have the solution faster. Okay. So once this road corridor, let's say, is created, then we can join them to make a single surface. And when we have two surfaces, again, we can calculate the volumes. We can calculate the volume between existing ground and the road surface, and you can see we get again the thin volume surface with the exact cut and fill volumes. Okay, and when this, let's say, now we can use this road corridor for a boundary, as a boundary for the existing ground. So we can cut off this part of the road corridor from the existing surface to get such nice, let's say, view of the road, and that would be quite good. I mean, or to use it for the visualization, because you can immediately see where the new let's say, object will be located. Okay. Next thing, what we would like to do, we would like to fill this accumulation with water. So again, we can simply use deform command, specify the surface, specify the location, and this flat surface is created in that area. In our case, it represents the water, and we can also calculate the volume. What is the volume of this accumulation? So again, thin volume, select one and the second surface, and we got this result, this let's say, entity again, and you can see what's the value, 48,000 cubic meters. Okay, so for the end, what I would like to say is that we are working on a platform, and for the platform, it's very important that it has the powerful API. We have developed, or it exists, the .NET and BRX APIs for the thin surface, thin volume surface, and the grading. So it will be available in V20, in the first release. All the civil functionality will be available in BricsCAD Platinum and BIM. maybe for very end, I would like to show you how we can create very simple API demo. Just let me switch the computer. Okay, so the same example as we used before. So with the API, you can use the API to do some specific functionality related to local standards or even companies, or you can automate some tasks. So with this simple example, what will do, it will automate the tasks, so it will create an accumulation, it will join the surfaces, and it will create a water surface at the end. So it's just a simple example. So first I will select this arc representing the crown. I will select the surface which represents existing ground, and you can see now we create a water levels for the different elevations. So first you can calculate the volume, you can do the analysis, you can do the simulation. So if we hide this, you can see we have several surfaces here for the different elevations, and we do have let's say just fill volumes in this case, and to the areas for different let's say levels of the water in this case. So thank you.